First, I want to greet the CS50 team and thank them for their hard work on the course. My name is Joseba Iribarren, and I'm from Valdivia, Chile. This is my final project for the CS50 course. It's a cellular automaton, CA, model for simulating the spread of forest fires using the ESA World Cover Land Cover model. The Flask application interface is quite simple, but the fun part is seeing the simulation. To do this, you simply click on a point on the grid, which is secretly made up of buttons. This starts the simulation. The simulation uses arbitrary ignition probabilities based on the type of land cover, which are displayed at the bottom. It modifies these ignition probabilities based on the topography, using the Microsoft Planetary Computer Elevation model. A hillshade is also extracted from this model to give the grid a 3D appearance. The second influencing factor is wind direction, for which a reference value was extracted from Automata using the API. A model was then generated showing how this specific surface wind value is modified by the elevation model, following the steps outlined in a 1975 paper by Jackson and Hunt. Therefore, the core of the code is the step function, which generates the next simulation state given the previous state. This function simply loops through the land cover array, modifying the ignition probability of each cover type depending on whether a neighboring land cover is burning and the wind and slope relative to that neighboring land cover. One interesting feature is that the app allows you to enter the coordinates of any location to generate the simulation. By default, these coordinates are for an area north of Valdivia. However, I can also enter the coordinates of Annenberg Hall, for example, and see the land cover of Boston, which is primarily urban and not particularly relevant for this type of model, but is still interesting.